Hi, welcome to Module 5 of this course on blockchain technology. You already went through the other four modules prior to this, and I'm sure you already have understood and you have learned the various concepts covered in the previous four modules of this course. Uh, my name is Dr. Mani Madhukar. I'm part of Global University program at IBM Research. In this course, we intend to cover a couple of topics around blockchain technology. So far, you already studied about what is blockchain. You already understood what is smart contract. You all have already, understood what are the various consensus mechanisms, and you also have understood, you worked on Ethereum as a platform for blockchain technology. In this particular module, we will talk about the Hyperledger Fabric. How is Hyperledger Fabric, different compared to other platforms? Why is it so important from an enterprise adoption point of view? What is IBM doing in this segment? How are we working with various clients? What solutions are we working on? That's what we'll be covering in this particular module. So before going further, uh, just to have a small recap, right? So you already understood the blockchain basics and the various consensus mechanisms, wallets, what are smart contracts, and likes of those. In this particular module, we'll start with the basics of Hyperledger Fabric, what typically a fabric is. Uh, so Hyperledger is basically a collaborative effort created to advance blockchain technology by identifying and addressing important features for a cross-industry open standard for distributed ledgers that can transform the way business transactions are conducted globally. So it's really important that we are talking about a cross-industry and open standard distributed ledger platform. So Hyperledger is a trademark of Linux Foundation and is the umbrella for a group of technologies which are designed to advance blockchain for businesses. Hyperledger Fabric is one framework which is underneath this umbrella. There are many other frameworks. Uh, typically, the contributors to this Fabric project are from developers from IBM, BTCC, Fujitsu, and many others. There are similar other frameworks under Hyperledger, including Iroha and Sawtooth, and a few more. One of the key differentiators from a Hyperledger point of view is the open governance model of the project. What it means is that there is no one organization which is controlling or governing the direction of the project, and no lock in to one particular vendor would be happening. So what happens is requirements for blockchain will vary greatly across different use cases. For fintech, it may be different. For supply chain, it might be different. So there will be not one size that can fit all the solutions. So Hyperledger is being designed to be highly modular with pluggable options to suit various different needs. Now, as far as Hyperledger project is concerned, Hyperledger project comes has certain goals to it, right? One, it creates an enterprise grade open source distributed ledger framework and a code base upon which the users can build and run robust industry specific applications, platforms, and hardware systems to support business transactions. One of the goals of Hyperledger project is to create an open source technical community to benefit from the ecosystem of Hyperledger solution providers and users, which are focused on blockchain and shared ledger use cases. And of course, they will work across variety of industry solutions. Also, it helps in promoting participation of leading members of ecosystem, including developers, service and solution providers, and end users. So that's basically a couple of goals from a Hyperledger point of view. Hyperledger Fabric, as we discussed, is one of the frameworks under Hyperledger umbrella. And it's one of the two Hyperledger projects that IBM is significantly investing in. And it's really important to understand that Hyperledger is not an IBM project. So it's a project under Linux Foundation. The version 1 was released in 11th July 2017. And at that point in time, it had developers representing 28 different organizations. Releases are normally, happening every 3 months. So we had version 1.1, which was released in March 2018, version 1.2, which was released in July 2018, version 1.3, which was released in October 2018, and so forth. right? IBM is just one of the many contributing organizations to Hyperledger Fabric project. So let's try to get us started with what we have as a learning for this. So it's just a quick recap of the various concepts that you already would have understood so far, right? So we talked about assets, we talked about contracts, we talked about transactions, we talked about business networks, we talked about participants, we talked about all of these things, right? So while there had been many blockchain platforms which have been adopted for enterprise use utilization, Fabric, Hyperledger Fabric has been designed from grounds up for enterprise use. So that's really important from us to understand. So from a enterprise adoption point of view for any blockchain platform, we really need to understand one thing. A couple of things. One, the participants must be identifiable, right? We cannot be doing business with anonymous people when we talk about enterprise blockchain. Number two, the networks needs to be permission, right? So it cannot be permissionless approach. So that's why when we talk about enterprise blockchain, we talk about private permissioned blockchain, right? Third, the enterprise application, for utilization, it's really important. We have high transactions throughput performance from the platform, and there is low latency of transaction confirmation. Why? Because there can be multiple players, who are part of the blockchain network, and hence it's really important that the overall latency for a particular transaction is low. And most importantly, it's really important again that the privacy and confidentiality of transactions and the data pertaining to the business transactions is maintained. So these are a couple of the concepts which have been utilized in creating a blockchain solution or having a blockchain framework up and ready. Let's try to understand consensus from a simple example, because then we will talk about how we have consensus implementation in Hyperledger Fabric. So let's say we have got 100 people in a room, right? And let's say 10 of them are mathematicians. So if you see this infograph here, there are participants, which we said, which are 100. And then there are mathematicians in the second row, which we said that there are 10, right? And then there is a presenter, right? Let's say I'm a presenter. Now, what happens here is we are putting a question across to everybody, all the participants. What's the question? The question is, what is the square root of 2401? So let's say if this question is actually pitched to all the mathematicians in this group, right? What typically happens is every mathematician will calculate the square root of 2401, and they write their answers on a piece of paper, and they sign the answer with their digital signature. It really helps in signing, because that way we have a proof that they are the ones who have put this answer on the sheet of paper. So the presenter collects the responses from every mathematician, right? And the room attendants, which we saw, which are marked as A in this infograph, they distribute the copies of the signed answer to all the members of the audience. So the answers which are provided by the 10 mathematicians have been distributed to the 100 audience that we have, in this network. Now, each audience member checks that every mathematician agrees the answer to the answer or not, right? Now, the great point would be, when there is a consensus, that means everyone is happy and, everyone agrees to what the other person has to say, right? A typical solution. Now, there can be multiple issues to this particular, scenario if we talk about. One, how many mathematicians should the presenter ask? So should I ask all the 10? Should I ask 2 mathematicians for the answer? Should I ask 8 of them for the answer, 6 of them for their answer? That can be one point. Second, how many mathematicians need to agree for an answer to be correct, right? So out of a quorum of overall 10 mathematicians, what is the number? What is that minimum number I should actually look, to arrive at consensus? Whether it should be 5, it should be 6. That if 6 people are agreeing to a particular answer, we should go ahead with that answer, right? That's another point. And another important aspect is what happens if the mathematician disagrees on an answer, or as a presenter, I select a wrong answer, right? So in order to constitute a good answer, everyone needs to agree what is the right answer or what is a good answer. That is basically typically a consensus building approach, right? So the importance of policy is key over here, right? So this policy formulates how do we agree on that one good answer. So the audience agrees to a policy, to accept a good answer. Some of the policies can be one, all mathematicians must agree that this is the right answer. If that is done, then everybody will accept an answer. Number one. Number two, we say if the majority of mathematicians, let's say out of a group of 10, let's say 60% or 70%, if that many mathematicians agree, then we have a good answer, right? So this is using this policy, everyone can now agree what actually makes a good answer. Typically, that is how we arrive at a consensus. Now, let's actually, take up this example here. This is a document, right? I'm not sure if you'll be able to realize, but recognize this. But let's try, right? In case you can take a pause, you can try to understand what's written there, and you can try to make out if you want to. So I'll just take a pause here. Okay. So this is actually a closing endorsement section of Constitution of United States. If you see the Constitution of India, you will also find a similar transaction endorsement there. So you will find multiple signatories, putting their signatures onto it. As far as Indian Constitution is concerned, we have a similar, signatories who have put their signature towards the end of it. Multiple copies of those are actually available if you actually go online and look for it. Now, what is really important from our point of view over here is, notice how it is signed, by a set of organizations and members. So if you see on the left hand side, there's an organization, and then which is followed by a number of members of the particular organization. Right? So the concept of endorsing affect, whatever it is, whether it's idea or a contract, is the basis of agreement the world over. In dispute resolution, such signatures are pieces of primary evidence that an agreement was willingly entered into by the signatories. So typically an endorsement means to support or approve something, right? So if you take a few examples, right? If in finance industry, in banking and finance industry, typically when I'm signing a check to transfer money to some payee, right? What do? I typically fill in the check. I sign the check with the exact amount I want that particular person to be given to, and then I actually cross-check that particular check and make it account pay, right? Similarly, if you see in an insurance industry, you often see a policy document which is endorsed by adding or removing conditions. Now, this saves the policy for having to be completely rewritten. It's like a template, which basically serves as a baseline for everybody, right? In India, the transport regulator typically is a RTO, and the entire driving and vehicle licensing is governed by that particular body, that regulation body. Now, similarly in UK, we have something called as DVLA, Driving and Vehicle Licensing Agency, which does the similar, perform the similar activities as an RTO does over here. So RTO or a DVLA is basically an approver to the changes in any particular person's driving license. Let's say, if there are any penalties, driving penalties being implemented on a particular driver's license, right? So whether to revoke it or whether to put only a fee to it, that changes, the approver for those changes is basically the RTO in this case, right? Now, from a Hyperledger Fabric point of view, right, how do we actually have these multi-party transactions conducted? So a transaction, as we already have understood, describes a change to a system, right? Whether you are issuing a check and the check is actually updating the overall balance in the account of yours, or you are receiving an academic qualification, right, with somebody signing your certificate there, anything of like that sort, right? So typically that's basically a transaction. Now, typically transactions are signed by single organization like a bank, or a single university signs a graduation certificate, something like that, right? But then when you talk about multi-party transactions, that is where basically where the Hyperledger Fabric comes and sits. For example, if you're looking to buy a car from some vendor, or maybe a car from a used car facility, right? So the buyer and seller, see, there are two people who are signing that car transfer transaction, right? Similarly, if you are working with some logistics company, so the delivering logistics and delivery companies both sign the parcel transaction, right? So there are more than one party who are actually doing the transaction over here, right? So on the right hand side of this infograph, what you see is a pseudocode and is intended to illustrate the various fields required for a transaction, right? This is typically depicting a car transfer, right, where we have identification for the asset, and then we have somebody who is a buyer and somebody who is a seller, and then you have to have both of them signing the document. Okay, so let's move on, right? So how do we actually have this endorsement in the Fabric? Now, Hyperledger Fabric is built on the idea of selectric transaction endorsement. Okay, what it also means is the rules governing the endorsement are expressed using an endorsement policy. Now, transactions are implemented as a request to invoke some smart contract or chain code. Either ways you can call it out. Now, endorsement is often an action in response to a request, whether you are supporting an endorsement or you are approving something, either of the two, right? So, for example, in order to pay for a goods or a services, I write a check, right? And the input is the request for a payment, which I endorse the check by signing it, isn't it? We just discussed this example. Similarly, for an insurance company, right, the reviewing a policy document will add endorsements before agreeing to it, right? Similarly, in the case of RTO, right, upon notification of a penalty from a court of law, they will add endorsements to a driving license. So overall, when you talk about the endorsement system or the endorsement policy, these are as a result of these rules that we talked about, the process of endorsement will result in an updated state or output of some description, right? So typically, when you transfer a particular car from one org to another org, let's say org 1 to org 2, so both org 1 and org 2 should be signing the document. So that's basically the transaction endorsement in this case. So let's try to take this example further, right, and try to understand how endorsed transactions get into the blockchain ledger. So in this example, we have a business ledger which is designed as a simple Fabric implementation. On the left hand side of this table, there are blue, ledger entries are reflected in blue one, and in the right hand side, if you see, the ledger entries are reflected in the red one, right? So the blue ones typically show business terms, right? In the ledger, and the red one basically shows how this will be surfacing in Fabric, what the transaction would look like, or who would invoke it and who might endorse it. So all that things are basically recorded in this table. So let's consider as an example, there are two cars, as an assets, car 1 and car 2. Let's take this example for this point of view. So here, org 1, if you see here, it starts a transferring of car 1. So org 1 is the initiator. Org 2 is the designated as a receiver of car 1. Okay. In the Fabric code, if you see towards the right hand side, this transaction is implemented as a transfer function, right, which is invoked by organization 1, which is the initiator. The transfer function requires two inputs from org 1, if you see towards the right. One, a car as an asset to be transferred, that is car 1, and 2, a participant who will be receiving the car, right, which is org 2. Similarly, if you see the other entries on this table, they are also implemented similarly. So if there are new participants like org 3 or somebody else, they are introduced in the business transactions and the endorsement policy subsequently, right? So let's go further and try to see, what will be the sort of responses which will be generated by the smart contract. So as you already understand, right, a smart contract or a chain code typically contains the business rules for each transaction. Invocations are proposed by the applications and are run in multiple places. Where all the chain code is deployed, it will be running in those multiple places. So a chain code functions as a trusted distributed application which gains its security or trust from the blockchain and the underlying trust or underlying consensus among all the peers, right? So it is the business logic of blockchain applications. So there are three key points that apply to smart contracts, especially when applied to a platform. What are those three? One, many smart contracts run concurrently in a network. We will see that in due course of time. Two, they may be deployed dynamically in many cases by anyone. And three, application code should be treated as untrusted, potentially even malicious, right? So these are the three key points that apply to smart contract. Now, most existing smart contract capable blockchain applications follow a order execute architecture in which the consensus protocol does two things. One, it validates the transactions and then propagates to all the peers, right? That's the first thing. Second is each peer then individually executes a transaction sequentially. Okay, so that's what if you see here in the infograph, it talks about what a typical, how the smart contract actually generates a response to a particular transaction. If you see here. Now, let's try to get into the various components and concepts of a fabric, right? So typically we are going to cover about how the fabric works. This is what will be the subsequent slides covering for us. In this introductory chart, we are basically telling what are the various components of a Hyperledger Fabric, right? So we have peers, we have ledgers, we have channels, we have application, we have policies, smart contracts, we have certificate authority, we have ordering service. So these are the various components. Please note the color coding because we will be continuing with the same color code as we go ahead and we show across the various transactions, the flow of the transactions happening, over our fabric, Hyperledger Fabric system. So in a typical fabric network, so we have peers, we have channels, which are the basic building block of a Hyperledger Fabric network. Now, each channel has a single ledger. So that way, it's really we can consider the scope of a channel to be equivalent to the scope of network, right? So in org1, there are two peers, peer 1, peer 2, right? And then these are connected through a channel. Similarly, in org2, there are another peers, P3 and P4, which are again connected through a channel, right? So channel defines basically the scope of the network. The scope of this channel can be local as well as across the entire network also, right? Each channel has a single ledger which is replicated to every peer which is a member of that particular channel. So far we have basically understood, how a Hyperledger Fabric works, what are the various modules. In the next lecture, we will cover the various policy mechanisms and we'll cover, how the various methods like evaluate transaction and all are invoked in a Hyperledger Fabric.